All right, this is Mr. Gillum, and today we're going to continue with completing the square. Okay, we kind of got a taste of it yesterday, and we learned the pattern there with those perfect trinomial squares. We learned the pattern. Today we're actually going to apply it to something relating to quadratics, okay, or parabolas. All right. Before we do that, what we're going to do is we're going to use this to solve equations, okay? Completing the square to solve equations. And believe it or not, this is an extremely useful tool, okay? We're going to do another thing later on. It's called the quadratic formula. It's a big, long hassle. If you can complete the square and do it quickly, it's going to save you a lot of time, okay? It's going to help you find the zeros. It's going to help you find the intercepts. It's going to help you on a lot of things, a lot of PSAE things, okay? So this is a really valuable skill if you can really learn it well. All right, so in our equations today, you're going to have the term, and I want you just to solve for the first two parts, okay? When you solve the first two parts of the problem. And so what I'm saying is, if you have something like this, all right, I want you just to solve for the x squared and the x. I want just the variables, both of them, on one side. Move the other stuff over, okay? If there's a number back here, move him over to the other side of the equation, okay, for temporarily. All right, so I just want to have just the x terms, the x squared and the x terms on one side, everything else on the other. All right, we're going to complete the square. Okay, and this is the exercise we did the other day with the c value. Okay, find the c value and add it to both sides is what we're going to do. Okay, the c value is b over 2 quantity squared. Okay, and remember, this is the guy, after we factor, that's going to go inside right here. X minus b over 2 quantity squared, or plus. All right, then we're going to square root both sides and solve and continue with our solving equations by taking the square root of both sides. All right, now this is really important. This method only works if the a value is 1. Okay, the a value is 1. So if this isn't 1, you need to divide it both sides by whatever it takes to make it 1. Okay, it needs to be 1 in front. Your solution might be square root of a negative, it might be square root of a positive, okay, it might be a real or imaginary number, but at the end of the day, you need to have your plus minus and all that stuff. All the stuff we talked about leading up to this. All right, so here's what I want to do. I want to solve by completing the square. So what I'm going to do is this, okay? Our other methods are going to be ineffective. This is not factorable, okay? So to complete the square, what I need to do is I need to solve for just my x terms, my x squared plus 6x. I don't want any other things on the left-hand side, so I'm going to minus 4 to both sides. So now I have x squared plus 6x, and I'm going to specifically do this. I'm going to leave a gap there, equals negative 4. Okay, I left a gap right here because what's going to go there is my square, my perfect square. Okay, so what I have is x squared plus 6x plus, I want to add something on there to make it a perfect square. Okay, I know it's b over 2 quantity squared. So I know what I want to use when I add to both sides is b divided by 2 quantity squared. Okay, b over 2 quantity squared. All right, and we did those problems yesterday where we had to find the c value. It was b over 2 quantity squared, and then we factor both sides. Okay, here's my b value, 6. I'm going to show my work specifically so that when I factor, it'll make it easier for myself. 6 over 2 quantity squared. That's b over 2 quantity squared, which is really 3 squared. Okay, and I wrote that for a reason. Okay, I'm showing my work for a reason, which equals 9. All right, so what I want to add to both sides to make this a perfect trinomial square is 9. I'm going to add 9 on this side. I just wrote it in right there. I'm going to add 9 on this side. Okay, remember, we're still dealing with an equation. Whatever you add to one side has to also be added to the other. All right, now the reason I wrote this out so perfectly here, I showed every little step, is because that 3 now is going to be part of my factor term. X, because it's plus plus, is plus 3 quantity squared. And I got this quantity by factoring this x squared plus 6x plus 9. Okay, this is the factored form right here, x plus 3 quantity squared. It's a perfect square trinomial. That was the goal, to make a perfect square trinomial. And we know that equals 5. All right, now we have an equation that we've been practicing solving for a while now. It's a quantity squared. I know to get rid of this squared up here, I can square root both sides. Okay, so we have x plus 3 left over equals plus or minus the square root of 5. All right, and so now what we can do is we can continue to solve. minus 3 on both sides. X equals negative 3 plus or minus the square root of 5. Now remember that negative 3 comes in front of the plus or minus. Okay, so my two solutions will X equals negative 3 plus the square root of 5, or X equals negative 3 minus the square root of 5. Okay, these are my two solutions. Okay, now that was just the first problem. Okay, instead of rewinding it and watching it again, just let's move on to the next one and we'll try another one here. Okay, this time, once again, we have x squared minus 10x plus 8. Okay, now 4 times 2 is not going to add up to negative 10. 8 times 1 won't add up to negative 10. Okay, there's no way to get to negative 10. We can't factor to solve, so what we need to do is find another method. Okay, today that method will be completing the square. So I need to solve for ax squared plus bx. I need to solve for this first part of the equation, okay? Because I'm going to use it to make a perfect trinomial. So I need to get rid of the 8, making x squared minus 10x. I'm going to leave a space for a reason, equals negative 8. What I'm going to put in this space is a number to make this a perfect square trinomial. All right, and we know from yesterday that to make this a perfect square trinomial, we take b divided by 2, quantity squared. So I'm going to take this negative 10, divide it by 2, and square it. And I'm going to show every little step of work here because I know that negative 5 right there, quantity squared, even though it's positive 25, and that's what I'm adding to both sides, this negative 5 is going to come back and it's going to be in my factored term. All right, so I'm going to add 25 to both sides, plus 25, plus 25. And the reason for doing that one more time is to get something I can factor into a perfect trinomial square. Then I can continue with my square root and do all that stuff. All right, so now that I've added 25 to both sides, I'm going to factor the left-hand side. X minus 5 quantity squared. And looky here, this is the negative 5 that goes in the parentheses right here. Okay, that's always the number that goes in right after the X. That equals 25 minus 8, 17. And so as you can see, now we can continue and square root both sides to get rid of the squared. Okay, we have x minus 5 equals plus or minus the square root of 17. And I add 5 to both sides. X equals 5 plus or minus the square root of 17. So my two solutions would be x equals 5 plus the square root of 17 or 5 minus the square root of 17. Okay, so there you have it. We're going to do a few more. Okay, they're not all this simple, it's straightforward. All right. This one, once again, it's going to be pretty obvious. 4 times 1 does not add up to 12. Okay, and 2 times 2 is not going to add up to 12, so there's no way to factor this by traditional methods. So we need an alternate method. So we're going to use completing the square to help us solve this. And remember, to complete the square, it's b over 2 quantity squared. I need to solve for ax squared plus bx. Okay, I want the x terms on the left, everything else on the right. So I'm going to move this negative 4, move this positive 4 over by subtracting 4. And it leaves me with x squared plus 12x plus a number equals negative 4. Now I left it blank there so I can fit this in a second here. I need a number that's going to make this a perfect trinomial square on the left hand side. All right, I know it's b over 2 quantity squared should give me something that's going to make a perfect trinomial square. So I'm going to take b over 2, 12 over 2 quantity squared, which is 6 quantity squared, which is 36. Now this 36 is what I'm actually going to add to both sides. The 6 is actually what's going to factor, plus 6 quantity squared. All right, and that equals 32 now. So getting here is the tricky part, the new part. From here we saw these in previous days, okay? X plus 6 quantity squared equals 32. We've done practice on those. We've done a lot of practice. This is the new stuff for today, okay? From here to here. All right, we're going to square root both sides. X plus 6 equals plus minus the square root of 32. I'm going to subtract 6 from both sides. X equals negative 6 plus or minus the square root of 32. Okay, so I have two solutions. However, I've done this before, okay? 32, the square root of 32 reduces, so we need to reduce it. 16 times 2, 4 times 4, 2 times 2, 2 times 2, and remember there's a little 2 out there that says for every 2 primes underneath I can pull one out. So I can pull a 2 out, pull another 2 out. I have a 2 left on the inside, so I still have that. I know the square root of 32 is the same as 4 times the square root of 2. So instead of the square root of 32, I'm going to cross him out right now. I'm going to put 4 root 2 in there. Okay, so my two solutions would actually be x equals -6 plus 4 root 2, or x equals -6 minus 4 root 2. Okay, and there's my two solutions. And as you can see, it'd be tricky to factor that and get that right answer. All right, so let's do some more. Okay, and this one is a little different. Okay, what we're going to do is we're going to solve for ax squared plus bx, same way. Okay, so I'm going to get rid of this 18. I'm going to get 3x squared plus 12x equals 18. Now, I didn't leave a space this time because we're not quite to where we need to complete the square. Okay, at the very bottom of your notes, you should say star, 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 star. If the a value is not 1, you need to divide both sides to make it 1. Here's my a value right here in front of the x squared. I see that it is not 1. This is 3 times x squared. I need to get rid of it. I need to get rid of the 3. So I'm going to divide this whole side by 3. I'm going to divide both sides by 3. Okay, I need a 1 in front of my x squared before I complete the square. Okay, so what I'm going to say is this cancels out and this cancels out. All right, this is important that you understand that it has to cancel out of the 3 and out of the 12. You can't just pick one of them. It has to cancel out of both terms. All right, therefore I have x squared plus 4x. Now I'm going to leave my space equals 6. Okay, now that my a term is 1, I can complete the square. So this is just like what we were doing before, b over 2, quantity squared. And the goal is just to get an equation to where I can square root both sides to solve. And that's what completing the square is for, to make it an equation where you can square root both sides. So I'm going to take my b value, 4, okay, divide it by 2 and square it. Okay, and so what I'm actually adding to both sides is 4. But I know when I factor this number right here is going to be in my factored part. X plus 2, quantity squared, equals 10. And from here we have an equation that we've solved before. We've practiced these before. We're going to square root both sides. X plus 2 equals plus or minus the square root of 10. I know that doesn't reduce, so right away I'm just going to subtract 2 from both sides. X equals -2 plus the square root of 10, or x equals -2 minus the square root of 10. All right, and so there's your two solutions. So what you should take from that example is if the a value is not 1, you need to make it 1.